Hello, students. Welcome back to your computer science class. I am Mrs. Jenny Shah, and we are learning Computer Science, Chapter 7 Manipulating a List. Today, we are going to learn how to make a true copy of a list. When we make copies of a list, there are two types of copies that we can do, shallow copy and deep copy. Today, we will learn about that. Okay. All right. So let's say I have made a list called numbers, and it has the numbers 1, 2, 3, 4, and 5. I make another list called new numbers and I initiate it or assign it numbers. Now I'm going to show you a couple of things. Number one, I have made a change in the new numbers list. Okay, the new list that I made, new numbers. I am changing the value or the element at the 0th position to 9. And next, I'm going to print the number list, numbers, and I'm going to print the ID of numbers, that is the memory address of that particular variable. At the same time, I'm also printing the new numbers, and I will also print the ID of the new numbers, the memory location. When I'm going to run this, you will be amazed to see that both the lists have the same value. The modification that I made on the new list is even reflected on the old list. In fact, both their ID values, that is identity numbers, is identical. It's similar. That means it's in the same memory location. Can you see the changes over here? Can you see how it's reflecting? Now, I'm going to use an inbuilt method called copy. Okay. Now, when I use this method, I'm using my old list. Let's say I'm making an old list, which is a list of lists, and new list, which is a copy of the old list. Using the copy method, I'm copying the old list into my new list. Now I'm making changes in the new list. Okay. Now when I'm printing my old list and my new list, can you see the changes? My old list has 1, 2, 3, whereas my new list has A, B, C. Yes? The first element, which was a list in itself, has changed to ABC in the new list, and it does not reflect in the old list. I'm sure if I was to check the ID numbers, they both would be different. Okay, now what I'm doing by doing this is, in my new list, in my 0th element, that is 1, 2, 3, or ABC, whatever, in that second element, I'm changing to C. Now you can see it's reflecting in both old list as well as the new list. So shallow copy actually creates a copy of the object, but references each element of the object. Now if I'm doing deep copy, Deep copy is creating a copy of the object and the elements of the object. Okay, what did the shallow copy do? It created a copy of the object, but it was still referencing each element of the object. But whereas in deep copy, it not only created an object of the copy, but it also created a copy of every element of that object. So in shallow copy, what used to happen is if I would just say bag 1 equals to bag 2 or bag 2 equals to bag 1, basically they are both pointing to the same set of objects, the same memory location. But if we go for deep copy, they both make their own copy of the object. Now I want to teach you one more thing. I want to teach you the difference between cloning and copying. So copy method is used to copy all the elements of a list into another list. When we copy a list, a separate copy of all the elements is stored in another list. Both the lists are independent. So if I have a list which has the values 10, 20, 30, 40, 50, and I say B equals to A, suppose, then my list B will have all the elements of list A and in the same position. When I say B equals to A dot copy, B will also have all the elements of list A, but in an absolutely separate ID, in an absolutely separate memory location. Both the list will be independent of each other. Modification in A will not affect B and vice versa. So any modification done in B will not make any changes in the modification of A. This is called copying a list. Now, let's understand what you mean by cloning a list. We can clone a list into another list using slicing. When we clone a list, a separate copy of all elements is stored in another list. Both the lists are independent. Taking the same example, I'm using B equals to A, start to end. So everything is going to be copied. But over here, every changes, modifications in A will not affect B and vice versa. Because we have used the slicing method. If slicing was not there, then the changes would affect in both the places. Okay, now over here, there are three examples. Both of them have the same values. Now we are modifying the A list, and let's see if the same changes is reflecting in list B. The change reflected in A, but it did not reflect in B because B is a copy of A. Now we are making changes in B. Let's see if it changes in A also. Like you can see, the change is only affected in the B part and not the A part. 66 is only in B and not the A. So they are both independent lists which are separate of each other. Modification made in one does not reflect in the other. Okay, with this, children, I end today's class. I hope you have understood what I was trying to tell you, that is the shallow copy and the list copy. With this, we end today's class. This is an inbuilt function list that can also be used to make a copy, which will again be a deep copy and not a shallow copy. Okay, read this part in your textbook. It's very well explained. Also, you can use the SIPO app with the inbuilt barcode and see the copy happening. They've also explained it very well. Feel free to use all those barcodes and see it happening. With this, I end today's class. Children, stay home, stay safe, take care, keep learning. Thank you.